I went ahead while y'all were working and I wrote in some stuff after I saw that everybody kind of at least got this far. But we talked about the fact that our percentages, they're going to be the actual whole numbers because we want the output to be the percentage itself, which is weird, but probably won't see it very much. Again, these 2 points right here should be no-brainers. But I know on this one you have to manipulate some stuff to get to the second one. But again, we talked about it on Thursday. I talked about it again on Friday. But you have to at least be able to get this point, okay? Now, let's say you could not figure out A and B, right? Just like, I don't even know what to do. It's giving me an error. Does that stop you from doing B or this B? No, it doesn't. You can actually do the whole rest of this, even if you can't figure out what to do with this, right? So just keep that in mind. Don't get stuck and stop. But there's your A and B. So remember over here, we had to, because when I had these as 0 and 5.5, which is what I was given, I got an error. So since it was t plus 1, I added 1 to each one of them, which gives me my correct A and B, but this function is wrong because it's just an x and I need x plus 1. So this is where our manipulation comes in. We only have to do it if it's a t plus 1 situation. You could have a logarithmic regression that's just straight up natural log and you don't have to do that stuff and you don't have to do it on the other ones. Okay, it's just kind of a unique situation because of our domain. So then I exported the equation. Here. Sorry, it doesn't let me scroll. And it had a y and just natural log of x, but I changed x to t plus 1 and I changed the y to s of t just so I could use it that way. You don't have to do that on all your regressions, but I needed the actual function anyway, and I can just turn that one off. So now my red one is my correct one, and I can see that when I'm at 0, I'm at 65, which is what I expected. I could also check myself on the other stuff. So then when I get here, even if I didn't have a nice, pretty equation in there, I actually know what S of 5.5 and S of 0 are, right? I know what they are, so I could actually type in these numbers. Or if it's something where I didn't make it into that function, I would still need to type it in. But this is all I have to write down. And because I defined my function as S of t, and this is a capital S, I got lazy because there's a lot of clicking up here. I use a lowercase s because nobody else see it but me, so it doesn't have to be perfect, right? As long as I do it right up here. But s's, you can't really tell if they're capital or lowercase anyway, so it's fine. But here, instead of me actually typing in the numbers, I can just do s of 5.5 minus s of 0 over 5.5 minus 0, but I can just do my 5.5, and there's my slope right there. Okay, so that answer is negative 7.63636. Okay, we all good? Average rate of change, we should be able to handle without any problem. Is that right? Yeah, okay, so that is my slope. Then it says, and this is very important that you all listen because a lot of y'all are wrong right here. Use the average rate of change found here to estimate. So use that average rate of change from right above to estimate the percent that did not own a smartphone at t equals 10.2 years and show the computations. Here's what I'm not going to do. I'm not going to go type in s of 10.2 or x equals 10.2 and figure out where it is, because that's using this function. That doesn't have anything at all to do with this. I have to use this right here. So here's what's happening, is that we have this function. So I have this curve, right? And we just found, so this right here, these 2 points, this will be like at 0, and this will be at 5.5. So this isn't really the x-axis. I'm just going to make a number line. But I found the slope of the orange line, because we cannot find an instantaneous rate of change without calculus, and we're not in calculus. So I can't find the average rate of change at 10.2 or at 5.5. I have to be able to do an average rate of change. Now, the closer those two numbers are, the more accurate it is to the instantaneous rate of change, but we'll get to all that later. But this is at 0, this is at 5.5. It's saying use the slope you just found. Instead of using the blue curve that is currently in Desmos, use the orange line to estimate it at 10.2, because this still is an estimation. If I, find it at 3 or whatever, that would be an estimation of what is on the curve. At 10.2, way over here, you know, I'm using the orange line as an estimation on the curve. We're not saying it's a good estimation. It's just saying use it as an estimation. We okay on that? So in order to do that, what do I need to write, or what do I need to do here? Point slope. So y minus y1 equals m times x minus x1. And I have two ordered pairs. I can pick whichever one I want. I'm going to use the 0 and 65 because there's a 0 in it. So that's y minus 65 equals negative 7.63636 times x minus x, which is 0. So the x, my input now, and it's okay that it's in y and x and we're using t because that's how we start to write at the equation. And it's okay that we don't make our equation into t's here. But I'm going to substitute that 10.2 in here. So that'll give me y equals negative 7.63636 times 10.2, and then add that 65 over here. Now, because I have my slope in Desmos right now, right here, that is my negative 7.636. I can just take this, multiply that by 10.2, and add 65. And that's where I get that number from right there, which means that S of 10.2 is about negative 12.89091. Now, what does that number represent? What does the output represent? The percentage of people that don't own smartphones. Does that make sense? No. Okay. But it's okay that it doesn't make sense. We didn't do anything wrong. And why doesn't it make sense? Because it's a negative percentage, right? Yeah, it's a negative percentage, and that would mean like a negative whatever percent. That doesn't even make any sense, right? But let's look at what's happening. You wouldn't have to do this on the actual question, but just because I want you to understand what's happening here, let's type in this equation. This is y equals negative 7.63636 times x plus 65. Okay. And again, you totally would not have to do that for this question, but my red curve is what's my actual estimate. It's still not really the actual function. It's the actual regression. It's still an estimation. But notice so right here, if I estimated it at like 6.3, that'd be a way closer estimation. But we're doing it at 10.2, where my line is below the axis. Is the curve actually negative there? No, so it's an estimation. It's a bad estimation, but it's an estimation. Okay, we okay on that? Nobody said it was good. It just said use it to find it. Everybody with me so far? Do you understand the difference in what we have here? This is our actual logarithmic regression. This is the equation, this is the line that we just wrote the equation of. Okay. Any questions at all at this point? Okay. Now this next part here, very wordy. Okay, very wordy. And the words can get confusing, and I understand that. So let's think through this. Don't let it get all jumbled in your brain. It says, consider the values that result from using the average rate of change found in I. And that's what this is. This is a value that's something I got from using the average rate of change to estimate the percentage of the adults for t equals p years, where p is greater than 6. Okay. Are these estimates less than or greater than the percent of US adults that do not own smartphones predicted by Model S? So what it's asking you for is, when we use the line, are the estimations more or less? And it's not just any time, it's when p is greater than 6. I'm going to redraw this picture down here a little bit. So here's my curve, right? Here's that secant line that we just found, okay? And that's not really my x-axis. I'm just using it as a number line, because if I really put it where it goes, it's going to be a lot, all right? But this is at 0. This is at 5.5. So this is my 6 and greater would be like right here, okay? Because sometimes the orange line is more than the blue curve. Sometimes it's less than, right? if I'm talking from 6 on, if P is greater than 6, are my estimates from the orange line going to be more or less than the blue curve? Less. Okay, do we all agree with that? Okay, so let's just write that down without an explanation. Now, if you already have some explanations written out, because some of you do, I don't want you to worry about trying to fix things, change things. Maybe yours is just fine, but the words are set opposite. But if you already have something written there, if you want to flip it up and like rewrite what I'm writing, and then you can kind of compare them, you can do that. All right, so here's what we're going to say. We're going to say, I'm going to try to use the words from here. Okay, using, wait, say, no, the values. Okay, values using average rate of change from I are less than values predicted by model S. Okay, so that's just the answer part. Is it less than or greater than, right? So values using average rate of change from I are less than values predicted by model S. Now, are they always less? No. Do I even care about always? No, I care about when P is greater than 6. Okay, when P is greater than 6. Okay, now we have to explain why. And it says, explain your reasoning, right? Explain your reasoning. Your explanation should include a reference to the graph of S and characteristics of the average rate of change. If I'm going to talk about my average rate of change with a graph, what would be very helpful to have written down? The fun chart. Okay, so I'm going to write down my fun chart. All right, so my function, my blue curve, is it concave up or down? Up. And is the function increasing or decreasing? Decreasing. Okay. Everybody good with that? All right, so now I'm going to say, it says I have to have a reference to the graph of S. So when P is greater than, so I said values using average rate of change from I are less than values predicted by model S when P is greater than 6. So then I'm going to say S is concave up and decreasing. Is S always concave up and decreasing? You sure about that? Yeah. It is. So since it is, I don't have to have a clarifier, right? I mean, I could, but I don't need to. So it's just that it always is. S is concave up and decreasing. Therefore, average rate of change, rates of change of S are increasing and negative. Okay. All right. We good so far? What do we call a line that intersects the curve more than once? Secant. Okay, so it's a secant line. All right, so that just talks about my function, right? We got to talk about the rates of change here, or like what does that have to do with anything? Then we can say that the secant line well, I should have started that differently, but that's okay. So this is how, like, when your words, you start something, you don't necessarily have to erase. But tell me about the average rate of change of that secant line. Is it increasing or decreasing? The average rate of change. The slope. Tell me about the slope of that orange line. It's unchanging. What's another word for that? Constant. So the orange line has a constant rate of change because it's a line, right? And is that rate of change positive or negative? Negative. Okay, so secant line has constant negative rate of change. That's a very bad sentence, but I didn't want to. I know sometimes I start writing, so y'all start writing, and then you have to erase. I would have said, I probably should have said, average rate of change of the secant line is, but it doesn't matter. I said the same thing. So here's what we're getting at. This blue curve here, right? The average rate of change is increasing and negative. And the orange line, it's just negative and it's constant. So that's why it's going to be less, because it's just going to keep being negative. You with me on that? Does that make sense? And I know that wording is weird. And I know the answer is probably a little weird. And it might make your brain hurt. And you might be thinking, I would never get all that stuff written down. It's not the end of the world. That's one of your 6 points. It's all good. All right. If you are really trying to knock out that 5, then you want to make sure that you can make some sense out of this. But if this isn't your jam, it's not the end of the world. We're not all going to, you can get a 5 and not get all 6 points on all of them. Okay. But not everybody's going to get all 6 points on all of them. Should we at least be able to get those first 4 points? 100%. Okay, 100% should be able to get those. And just because this one makes your brain hurt doesn't mean we can't do this. All right. So this says Model S, and it's not asking me, it's telling me Model S is a valid model to estimate the percentage of U.S. adults that do not own a smartphone as long as the predicted percent is greater than 0. Explain how this information can be used to determine the domain limitations for the Model S. Okay, so let's look at this. Here's my red curve. That's Model S. We can ignore the line now. The whole thing is not a good model, right? It says as long as the percentages are greater than 0. How do we figure out when they're not? How do I know what I'm looking for here? What represents the percentages? The y. So how do I figure out when the y becomes 0 and becomes negative? Yeah, what's the x-intercept? It's right there, right? That's where it's 0, so then it becomes negative, right? And so that's why this one didn't make sense way down here. At 20, it's not going to make any sense either. So we can say domain of S should be, now we're starting at 0. I know I'm starting at 0, and I know I include it because that's something they gave me, right? And then I'm going to go all the way to 17 point something. 1, is it 11674? 11674. Do I get to include that? No. I do not get to include that. All right. And so then I can say S of t equals 0 when t equals 17.11674. And what are the units on t? Years. Okay. Years. S of t equals 0 when t equals 17 blah 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 years. After that, percentages are negative. Or percentages are less than 0, or there's different ways to word it. But understanding that domain is not that big a deal, especially when it tells you exactly what we're looking for there. Okay? Yes, ma'am. Why do I not include it? Because that's when it's 0 and it says it has to be greater than 0. Okay. All right, so you can, I punched holes in that. You can either put it in your binder. If you want to put it in your ISN with the other yellow ones that went with 214, that's fine, whatever works for you. Okay, but that's a very good example of your FRQ.